Excelentíssimo senhor presidente dos Estados Unidos, peço asilo político para eu, meus filhos, família e Júnior, tem quadrilha de tráfico humano, falsificando a doação e querendo pegar estudante de medicina pedófilo para querer pegar meus filhos. Meu procurador é Júlio, delegado da Polícia Federal, com Duda e com Barra. Peço ser fiel ao ministro do STF para sempre só falar a verdade. E peço a licença ao ministro do STF para colocar o nome dos boi aqui, dos que está fazendo crime. Peço ao Fantástico, que eu chamava a CM de pai, para ir na casa do pai do médico de coração, que é tio de Léo, que o Léo pegando a Bárbara, levando para lá para o médico de coração e pegando a amante dele, juntando, segurando os dois para bater em Bárbara. Bárbara não aguenta mais ser torturada. Por isso que Bárbara está toda intoxicada de remédio, dando remédio e levando para bater e para espancar. Dizendo que estava batendo com a blusa do Rosa, dizendo que estava batendo, porque Bárbara era do azul, que eu era do azul de Assembly. Sou mesmo. E eu votei no governador por causa de Júnior, que me liberou. E Júnior foi muito bom, liberou. Agora não é para pegar, botando gente do Rosa para que está querendo pegar, bater em Bárbara, não. Botando amante para bater em Bárbara, não. Não há nada que a NASA não vê. Peço, pelo amor de Jesus Cristo, à Polícia Federal, para colocar o gema em Léo, que Léo agressou essa família do Boa Vida. Não tem uma mulher que não disse que eles não espancam. Eles têm que tomar providência, porque eles é polícia e espancam a mulher. Agora, tudo mija na rua. Quando vai para uma diligência, quando vê um bandido mesmo, eles tudo mija de medo, que o Ângelo só anda mijando. E a NASA viu o Ângelo querendo pegar, levar Júlio também para o céu. E a NASA viu eles querendo matar CM Neto para não ter concorrência aqui na política. Não coma nada na mão de ninguém nos prédios, a NASA viu nos prédios, porque eles vão convidar, ninguém sabe se é para comer ou para querer, para depois dizer que a CM morreu, foi de coração de nada. A NASA viu, eles também fez dope com Júlio, que Júlio estava aí estava dormindo aí que botaram e botaram para dormir parecendo um negócio lá botaram no lugar para dormir, não coma nada na mão de ninguém. Eu estou aqui 3 dias, vou ficar aqui 3 dias sem sair, que Júlio pega a receita de Dr. Bento, que Dr. Bento é médico é médico pela vida, a receita de Dr. Deraldino para Duda, para Bárbara, para minha neta, que a Polícia Federal eduque Duda, Bárbara e Helena, do jeito deles, para formar um homem de amanhã. Não precisa tocar a mão, basta conversar, que Duda atende. E Júlio, estou pedindo, pelo amor de Jesus Cristo, você ganhou a Maria Bonita, que aqui eu não traio, não. Ontem mesmo a NASA viu, ela recebeu 2 bilhões para querer te dopar. E ela está com vaso, assim, parecendo de produto natural, botaram para Júlio, aqueles produtos natural para pegar, comer. Não come isso não, é dope. É dope, os produtos naturais. Aqui minha casa, a comida é toda feita, toda inspecionada, então você venha, coma, venha logo, vou arrumar seu quarto todo arrumado, Duda tem Dr. Flitz, venha junto com Duda para comer e beber. E peço à Polícia Federal para coibir, porque se o baldo do gatos fazendo ocorrência de gatos e pegando Bárbara para querer me sedar. A NASA viu o César do Foro de Itaúna pegando polícia para querer pegar Bárbara, o PM lá que é parente dos Borges lá de Itaúna, para querer pegar Bárbara. Porque eu entreguei para o STF o tráfico humano que está tendo aqui, eles falsificando a doação e pegando meus filhos com laudo falso de coração e suicídio. Pelo amor de Jesus, Polícia Federal, vai no aeroporto, na Casa de Glória, onde está Duda, fique perto de Duda e vá onde está a Bárbara, e que o Fantástico e a CM Neto façam um escândalo no aeroporto onde está Duda, na rua Padre João, número 26, onde está a Bárbara, e aqui na travessa Doutor Alfredo José Guimarães, bloco 10, São Luís. E a NASA viu o Nilson pegando nem falsificando relacionamento porque está com a doença grave, querendo entrar dentro da minha casa para comer e beber. E pegou a puta, ele que pegou a puta empreguete dele, levando para a roça, em bicicleta, levando em carro, levando tudo, fez barriga, e querendo botar Júlio no presídio para dizer que é da Polícia Federal, para dizer que é dos outros. Então, peço à Polícia Federal para pegar, como a NASA viu o doutor Carlos, que viu aí que o pessoal criou em 3 lugares, não está, não, um ser humano não fica em 3 lugares ao mesmo tempo. Doutor Carlos e Danilo do Bombeiro, que sabe que ele jogou Bezocriou aqui querendo vir pegar. E pegando nem, botando arma para falsificar relacionamento, para querer entrar aqui, para querer pegar, dopar e botar Júlio para vomitar. Foi eles que botou Júlio para vomitar. Não coma na mão de ninguém, Júlia. A comidinha aqui, eu já lavei minha mão toda com que boa. Vou começar a fazer a comida toda monitorada e não deixa a Bárbara vir para aqui. Porque peço ao STF para proibir, para ficar perto de Bárbara e pegar esse agressor e botar no presídio, que um homem que junta com outro amante em casa de médico de coração para espancar uma mulher que tem um filho, ele é monstro, tem que estar no presídio. Para botar Léo e o tio dele. O tio Klebe, que tem um filho que é médico de coração, no presídio, que essa família dos Boa Vida são valentes só dentro de casa, só homens são dentro de casa. Na rua vira uma moça e roda a bolsa. Chora tudo quando vai na diligência. O Ângelo mesmo chorava que César, policial militar, tinha um ódio dele desgramado, que ele queria ser valente dentro do quartel, quando ia para a diligência, chorava de medo dos bandidos, quando solta Ângelo, Léo, tudo na mão dos bandidos, aí para ver como tudo chora, porque dentro de casa é valente, junta com amante para bater em mulher. E meu procurador é Júlio, delegado da Polícia Federal, com Duda e com Bárbara. Aqui na minha casa, só a Polícia Federal. E o Nilson está querendo botar Júlio no presídio, mentindo, pegando empreguetes para botar barriga, em Júnior, em Júlio, em todo mundo aqui. Cuidado, querendo pegar na comida. E a NASA viu, foi dope, fizeram dope na comida de Júlio, botaram dope, viu o dope assim também, numa vasilha assim, com tampinha azul. Cuidado, não coma nada na mão de ninguém, Polícia Federal. Seja igual eu, não como nada na mão de ninguém, não deixa Duda nem Bárbara comer na mão de ninguém. Obrigado, Jesus, por tu existir, Polícia Federal. Se tu não existisse, eu não estava aqui. E não vai embora não, Júlia. Júlia, a NASA viu querendo ir embora, que já não aguentava mais dessa quadrilha. É isso que eu sofri, para tu ver o que eu sofri. Jogaram gás em meus filhos, jogaram tudo. E peço ao ministro do STF para botar a puta da Netinha extraditar, entregar aos Estados Unidos, que pegou oficial querendo cegar os olhos de Helena, querendo pegar os olhos de meu filho e meu neto. Essa puta aí, que doutor Bento, que quando teve uma irmã que forjava a casa toda limpa, forjava cena, doutor Bento chamou a Polícia Federal, e já vou começar a fazer o almoço, para depois começar a fazer a faxina na casa, mas antes de fazer o almoço, eu vou arrumar o quarto aqui, especialmente para a Júlia deitar, para a Duda, não vai embora não, Júlia, não fica por aí, deitando não, o quarto aqui limpo, para tu e Duda, vem para casa, pelo amor de Jesus Cristo, que estão tudo com puta, botaram, a NASA viu, botaram 10 putas para pegar, para querer fazer barriga com a Polícia Federal, 10, tudo arrumada, para querer fazer barriga. Vou arrumar o quarto aqui para Júlio, para Duda, porque aqui é seguro, aqui Aqui é Maria Bonita, que não se vende, não trai. E tudo que eu dei a Júlia e a Duda para comer, eu como antes. Obrigado, Jesus, por tu existir, Polícia Federal. Se tu não existisse, eu não estava aqui. Essa é a casa mais cheirosa do Brasil. Lucas Bandidos, paletó de bosta, pegando polícia para querer pegar a Bárbara. E a NASA viu um polícia que mora aqui, um PM, querendo pegar a Bárbara também. Tudo de condomínio, uma máfia que está aqui dentro de Jiquié. Isso não foi a polícia que eu conheci, a polícia que eu conheci, se mexesse com o filho de um, mexia com o filho de todos. A polícia que viu filho de polícia é policinha também, os colegas fazendo agressão em colega. E o Léo, quem bateu em Bárbara, eu pensava até que foi do sindicato, não, a NASA viu. Foi na casa aparecendo, e parecia também o fundo da delegacia lá o fundo da delegacia lá de Itaúna. E parecia também a casa de Kleber, pegando Bárbara e batendo lá. Então, peço a esse que bateu em Bárbara para a Polícia Federal quebrar toda no cipó. Quebrar e matar. Quem pegou meus filhos. Agora eu vou fazer a comidinha. Vou arrumar o quarto da Polícia Federal de Júlia. Doparam Júlia aqui em Jiquié. A NASA viu.
Sometimes make it too easy when they say we can replace all that by robots, we can do all that automatically. Maybe, possibly, you could do that, but then you really need to hope that you predicted everything, that nothing is going to go wrong. It's the humans that make the space station, not the equipment itself. The people that, for the past 20 years, have been in space and on the ground designing experiments and making sure everything goes smoothly. Together, they've made scientific discoveries about heart health, bone loss, growing plants in space.
Tudo de Júlio da Polícia Federal para tomar conta de eu, Duda e Helena. Assim, uma procuração em branco, tudo meu com a Polícia Federal. Não coma, eu já falei com a Polícia Federal, não coma nada na mão de ninguém. Na mão de ninguém. Foi dope que fizeram com o Júlio. Botaram o remédio. Por isso que vomitou. As putas do café.
It gets to the heart of what makes us human, dreaming big and making those dreams a reality through collaboration. For the past 20 years, we have been spacefaring.
Pega a linha direta que pegou o tio de Léo. Puta do café, tudo fazendo dope, querendo fazer barriga na Polícia Federal para não apurar. Puta dos cílios também.
People should not think that the space station is less than that. You know, we have demonstrated as a community for 20 years. We've shown every day that it is possible to live in space with continuity, without interruption, with an international community. And I don't know how many people would have bet 20, 25 years ago that it was going to work in the end so smoothly. For me, it's just humbling to think that I had the privilege of being part for a short time of this amazing success story.
E que SM Neto chama Vespasiano, vai ficar perto de Vespasiano.
During her stay on the orbiting laboratory, Samantha traveled 84 million miles and helped oversee almost 100 experiments.
Sharmila continues to launch fruit flies into space, where the latest rotation of station astronauts are there to greet them.
Chama a linha direta para
Most
esse
of us won't
agressor
make it onto the space station. But that doesn't mean we can't see it.
dos boa
The
vida.
big array of solar panels that power the station reflect some of the sun's light. That means around dusk or dawn, you may be able to see it zooming through the sky. Humanity's outpost and laboratory in space. A global collaboration that persists through conflict. A beacon of hope. This is NASA's Curious
Me
Universe.
respeita, arranja um relacionamento para querer pegar força.
Our executive producer is Katie Atkinson. The Curious Universe team includes Maddie Arnold, Michaela Sosby, and Vicki Woodburn. Special thanks to Erin Anthony, Rachel Barry, Ryland Heggie, Nicole Rose, the International Space Station Research Integration Office, and the European Space Agency. To keep up with current space station research, follow the @ISS_research on Twitter. If you liked this
Que
episode,
Pablo, delegado
please let us
federal,
know by
castro
leaving us a review,
pedófilo neto,
tweeting about
estudante
the
de
show at
medicina
NASA,
também.
and sharing with a friend. Still curious about NASA? You can send us questions about this episode or a previous one, and we'll try to track down the answers. You can email a voice recording or send a written note to nasa-curiousuniverse@mail.nasa.gov. Go to nasa.gov/curiousuniverse for more information.
Hey, Curious Universe listeners, I'm Gary Jordan from NASA's Houston. We have a podcast. I hope you enjoyed this first episode of the new season of Curious Universe. We have some more great content coming your way, so make sure you're subscribed to Curious Universe to get the latest when they post. Maybe this episode has scratched an itch and you're dying for more space between your ears this month. Well, you're in luck because Houston We Have a Podcast has some special content coming up just for you. This week and next, we're diving into the Crew 1 mission, the first crew rotation mission to the International Space Station on the SpaceX Crew Dragon. We're talking with the astronauts flying on the spacecraft and the flight director that's leading the operations from Mission Control in Houston. And we'll be posting double episodes, that's right, 2 episodes per week for the weeks leading up to the 20th anniversary of continuous human presence on the International Space Station coming up later this month. Stay up to date with us by subscribing to Houston We Have a Podcast on your favorite podcast app, or find us and other NASA podcasts at nasa.gov/podcasts.
OSIRIS-REx is a grand adventure of exploration in deep space. We built a robotic spacecraft, and we launched it off the Earth, and we sent it to a near-Earth asteroid named Bennu.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm Patty Boyd, and in this podcast,
Fazendo dope,
NASA is
fazendo
your tour
ocorrência
guide.
de gato e fazendo
NASA
dope de
has sent a
psicopata
robotic
de remédio.
spacecraft billions of
Fazendo
kilometers
dope
from Earth
aqui.
to do something we've never done before. Collect a sample
Que o
of an
exército
asteroid.
extradite. A
This
bandida
episode,
da
we're
Netinha
exploring
pegando
asteroid
polícia
Bennu,
para querer pegar
the
Júlio.
target of
Chama
our
Maurício.
OSIRIS-REx mission.
E o Papa, que ela ia tirando os olhos de minha neta.
Culmination of an enormous amount of work by thousands of people all around the planet. We are getting ready to send our spacecraft down to the surface of asteroid Bennu to collect our sample.
That's Dante Loretta. He's the principal investigator on the OSIRIS-REx mission. He's been with the team since the very beginning, 2004, preparing for this exact moment.
Our goal is to get the treasure off the surface of that asteroid. We're scientists and we're geologists, and our treasure is in the form of rocks.
But these aren't just any rocks.
These are very special rocks. These are rocks that are older than the Earth, that date from the formation of the solar system, and they hold clues to why the Earth is a habitable planet, why we have oceans here, and maybe why the origin of life occurred. So we have the amazing objective of bringing those rocks back to the surface of the Earth so we can get them into our laboratories and study them in great detail.
It's the first time an American spacecraft will attempt to collect a sample of an asteroid and deliver it to Earth. Scientists hope OSIRIS-REx will bring back the largest cache of dirt from space in half a century. Like moon soil from the Apollo era that scientists are still analyzing in their labs today, soil from Bennu will be preserved for decades to come. Future generations will have a chance to analyze it. People not yet born, using techniques not yet invented, answering questions we don't even know to ask yet. And scientists like Dante can't wait to get their hands on these samples. Studying asteroids is important for a few key reasons.
One is they are the oldest geological samples from the formation of the solar system. Literally, the oldest rocks that formed around the sun are found in asteroids.
So what would NASA want with a bunch of old rocks? Well, analyzing those ancient rocks will help scientists understand the early solar system in a way that studying Earth rocks can't.
Those rocks don't exist on the surface of the Earth because the Earth is a very active geologic body. It's got volcanoes, it's got rain, it's got erosion, it's got plate tectonics. So these rocks in the asteroids, they're over 4.5 billion years old. There's nothing that old on the surface of the Earth.
Bennu is a deep space time capsule, a leftover fragment from the tumultuous formation of the solar system. It's been well preserved in the vacuum of space for billions of years. Some of the mineral fragments inside Bennu could be older than the solar system. These microscopic grains of dust could be the same ones that spewed from dying stars and eventually coalesced to make the sun and its planets nearly 4.6 billion years ago. Bennu's makeup excites scientists. It's thought to be rich in organic molecules, which are the building blocks of life on Earth. And it's got the ingredients of another very important molecule locked inside its minerals.
And you'll probably be surprised, but it's water. Water in space is incredibly valuable for a couple of reasons. Primarily, you can break it apart and make liquid hydrogen and liquid oxygen. And that is one of the most powerful rocket fuels that we know of.
The presence of water ingredients on Bennu means that one day we may be able to use asteroids like space gas stations.
You could have a spacecraft that's using liquid hydrogen and liquid oxygen, and then it could stop at Bennu and get refueled, or you could bring that fuel back even to around the moon or near Earth orbit, and you could use it to refuel vehicles there.
Studying Bennu will also help scientists understand the hazards of near-Earth asteroids.
Bennu is also what's called potentially hazardous, which means it has a reasonably high probability of impacting the
Bandidos fazendo Doppler
creating a
GTL.
widespread natural disaster. And I don't want anybody to panic because the impact would be not for at least 150 years, but still, it's something I feel as a species we should be studying.
Bennu is one of the most potentially hazardous near-Earth objects currently known. It's as wide as the Empire State Building in New York City is tall. And it has about a 1 in 2,700 chance of impacting Earth sometime between the years 2175 and 2199. Our ability to make a detailed study of the asteroid now helps us prepare for the future, should Bennu stay on a course towards Earth in the next century.
It's kind of a gift to the future to go out and characterize this object, because it's likely that some point
E a NASA viu, minha comida aqui é ouro, ouro e diamante. Quem come aqui é 10 anos sem uma gripe.
There's a lot of information locked up in the rocks and dirts on Bennu's surface. But before scientists on the ground get the opportunity to study those samples, OSIRIS-REx has to collect them. The spacecraft launched in 2016 from NASA's Kennedy Space Center in Florida with this goal in mind.
Go Atlas. Go Centaur. Go OSIRIS-REx.
Everyone is go. Standing by for launch. And liftoff of OSIRIS-REx. Its 7-year mission to boldly go to the asteroid Bennu.
Since launch day, OSIRIS-REx has had its eyes set on asteroid Bennu. For 2 years, It's made its way to the asteroid and has been in orbit ever since, circling the asteroid and mapping its surface in great detail, all in preparation for October 20th, the day it will attempt to grab a sample from the surface. On the ground, OSIRIS-REx engineers like Ron Mink have been preparing too.
As a systems engineer, part of my job is to identify the bad things that could happen and to prepare for them. And so I'm thinking about risk all the time. Now, Bennu, the asteroid, hasn't been very compliant with what we need its surface to be.
We first saw the asteroid in August of 2018, and that was one of the most exciting days of my life. Something I'd been planning for well
E só
over a
corre
decade.
meus filhos, eles puxando o cabelo de Bárbara, batendo e puxando o cabelo de Bárbara, batendo na cabeça.
And then the
Pra
asteroid
botar
got
um
more
monstro
resolved,
desse no
and I
presídio.
just had this sinking feeling in my stomach because the surface looked really rough, rugged, and rocky, and not what we were expecting.
Our sample collector, we need to have, particles that aren't much more than
E querendo carregar meu filho para soltar no lixão, que a web fica ligada aí.
There aren't very many places on Bennu that have grains that small, and so we think we found the sweetest spot on the asteroid, and we're going to go there. But Bennu may not want to give up her secrets. That's probably my biggest concern. We've done everything we can, but that's part of exploration.
Space exploration means being vulnerable, and sometimes trying things that no one has tried before. The OSIRIS-REx team has done everything they can to prep the spacecraft for its sample collection. They've even gone through rehearsals for the big day. Finding the right spot, one that's clear of filters, is key. It wasn't easy, but the team found such a spot. They called it Nightingale. It's a 52-foot wide, relatively clear area inside a crater, a rare sighting on Bennu. And if Nightingale doesn't work out, the mission team picked a backup site, dubbed Osprey, where they can try for the second and final time to pick up a sample. These sites have the most evidence for fine-grained material on the asteroid and give OSIRIS-REx the best shot at collecting the sample. After years of hard tests, we'll get the opportunity to unlock secrets of the early solar system. Even though the talented team is prepared beyond question, in space there's always a risk that things might not go according to plan.
Even though we found a nice spot where we think there's lots of material that we can sample from, there's still some pretty big rocks around that site. The biggest one I call Mount Doom. It's about 10 meters tall, and it's just off to the east of the crater, and we absolutely do not want to fly into that. One of the things that might happen is it might tip over and start to move in another direction, and then it fires its engines to leave the asteroid surface. It could fly right into Mount Doom if it did that, if it tipped over too much.
If the team can safely capture a sample from Bennu, a huge deal. For Dante and the team, there's a lot riding on this moment. It's the culmination of many years of hard work for an entire team. On sample collection day, the stakes are high.
We are getting ready to send our spacecraft down to the surface of asteroid Bennu to collect our sample. As you can imagine, there's a lot of excitement, there's a lot of anxiety, and there's a lot of nervousness to make sure everything goes well. I've been working on this program since 2004. Almost 17 years of my career has been focused on this one day to make sure everything goes according to plan. We have thought through everything that could go wrong on that day, and we've done our best as a team of engineers and scientists and
OSIRIS-REx was designed with these steps in mind.
So OSIRIS-REx is a robotic spacecraft, and it is designed to operate around an asteroid. And they go down to the surface. Some very special features about the spacecraft that allow us to do that.
OSIRIS-REx has a number of science instruments on board that will do things like map the surface of Bennu and provide information about the minerals it finds there. We've also got cameras and sensors to help it navigate, and an arm that will collect rocks and dirt from the asteroid surface. Even though OSIRIS-REx has the right tools to get the job done, sample collection can be pretty tricky.
Get onto the surface into a small size space with our spacecraft in order to collect a sample. When you're doing that from 200 million miles away, it takes a lot of practice.
That's Heather Enos. She's the deputy principal investigator for the
Vou lavar o banheiro para vocês verem o banheiro mais cheiroso do Brasil.
process called tag.
So tag is touch and go. And what we mean by that is
Queria
literally
matado por...
reaching out with the arm of a device, and we are touching and going. We don't land on the magnet. We actually literally kiss the surface with the end of the arm. We're kissing the surface for about somewhere between 6 and 16 seconds. So it's a really, after all of these years, it really all happens in less than 20 seconds.
But leading up to that moment, Heather and the team will observe as OSIRIS-REx swoops closer and closer to the asteroid's surface, preparing to make contact.
The day of tag, it's about a 4.5 hour sequence, we call it, and we will leave orbit. Currently we're in a safe orbit, we call it, around Bennu, and we will command the spacecraft to get out of its orbit and start to slowly descend onto the surface of Bennu.
The spacecraft is going to fire its thrusters and leave orbit and very slowly approach the surface of Bennu, taking images along the way.
OSIRIS-REx will use those images and compare them to an existing catalog of the site. This helps the spacecraft to make sure it's headed in the right direction. The whole time, OSIRIS-REx is going through the steps on its own. There's no one controlling OSIRIS-REx in real time from the ground.
All of this is preloaded, autonomous, and so once we hit go, everything becomes autonomous.
We're going to send up a set of commands that basically tell the spacecraft what to do from leaving orbit until leaving the surface. So it's on all automated commands. We don't have a joystick, or a Xbox controller here on the ground to tell the spacecraft what to do, because there's going to be about a 15 to 20 minute delay in our signal. So we can't talk to the spacecraft in real time that way.
It's all pre-planned. OSIRIS-REx is fully autonomous. It begins to descend closer to the asteroid's surface.
At that point, we're about 125 meters from the surface, and that's our first opportunity to do our position and velocity checking and to make sure that our trajectory is on target. So then we would continue to go down a little bit slower even yet, and then we do another check, which we call match point, and that will be at about 40 meters above the surface. And then we have what we call our tag SAM arm, touch and go arm, that is then deployed, and we slowly descend to the surface.
OSIRIS-REx will aim to collect at least 60 grams of dirt and rocks, equal to about 30 sugar packets. It does that by stirring up the asteroid's surface. Think about a reverse vacuum cleaner.
We actually use a gas bottle of very high purity nitrogen to blow down on the surface in order to get the soil to move and to be agitated, because otherwise, with no gravity, things don't move around, and so we're forcing movement by blowing it down with the high purity nitrogen. It's a very clean, pristine gas, so we're not contaminating the surface with anything we've brought along.
After stirring up the surface, the samples will float up into a chamber. Once OSIRIS-REx successfully secures them, the spacecraft will slowly drift away from Bennu until it reaches a safe distance, and it will stay there until its departure, March 2021, preparing for its return back to Earth. When OSIRIS-REx reaches Earth in 2023, It will drop the capsule with the samples packed inside into Utah's West Desert, where scientists will be waiting to collect it.
We really refer to it as the mission that keeps on giving. And the reason that we call it that is we're bringing back this precious material back to Earth, and it's going to then be analyzed in laboratories, at the macroscopic scale that we cannot do remotely.
And getting these samples back to Earth will be a huge deal. It could literally change what we know about the history of our solar system. That's why the day of tag will be an emotional one for the whole team.
To get here, it really has taken a lot of time and a lot of people's passion and a lot of sacrifice. So you become personally attached to the spacecraft. It becomes human. The instruments become human. And it's not just a team after this many years of sharing this hard work and sacrifices and common passion with your team. It really becomes your family.
We hear a lot about the planets, Mars and Venus and Mercury. There have been, fabulous missions to all those objects, and they're, some pretty incredible science and some incredible pictures. But what I love about asteroids and comets is that each one of them is their own unique small world, and there are, literally tens of thousands, or depending how small you want to look at, millions of them in the solar system that we can explore. And so, I look at Bennu as not just a base rock or the flotsam left over from this formation in the solar system, but rather a unique world all of its own that has its own beauty, its own secrets, and also in the case of Bennu, its own dangers.
OSIRIS-REx, it's an extension of me in so many ways. It's hard to explain, and it sends chills down your spine because you're like, wow, we're an amazing species. The human beings built this robot, and we sent it out on this 7-year, billion-kilometer journey to go get this material so that we can study it in our laboratories. OSIRIS-REx is all about inspiring the next generation of scientists and engineers and leaders to go after something big, whether in space exploration or in any field that you're passionate about. You can make it happen, and when it does happen, it makes your whole life worthwhile.
This is NASA's Curious Universe. The Curious Universe team includes Maddie Arnold, Michaela Sosby, Margot Wohl, and Vicki Woodburn. Our executive producer is Katie Atkinson. Special thanks to Ryland Heggie, Ronnie Grant, Nancy Neal Jones, Lonnie Schechtman, and the University of Arizona. You can follow OSIRIS-REx as it completes its tag attempt in real time. Go to www.nasa.gov/OSIRIS-REx. If you liked this episode, please let us know by leaving us a review, tweeting about the show at NASA, and sharing this episode with a friend. Still curious about NASA? You can send us questions about this episode or a previous one, and we'll try to track down the answers. You can email a voice recording or send a written note to nasa-curious-universe@mail.nasa.gov. Go to nasa.gov/curiousuniverse for more information.
Que quarto mais cheiroso, hein? Eu faço como o doutor Deraldino falou. Nós expiramos o nitrogênio, respiramos o oxigênio. Eu viro todos os colchão, aí ó o colchão, ó. Viro todos os colchão, lavo todos os lençol, todos os dias. Minha casa é igual um hotel. Aqui é os colchão virados, ó.
This is NASA's Curious Universe. Our
Abra a
universe is a
janela. Nesse instante eu
wild and
fechei a
wonderful
janela porque
place.
tá saindo
I'm
cheiro
Patty
de
Boyd, and in this
sovaco aí. Deve
podcast,
ser de gente que não lava o
Lisa is
sovaco.
your tour guide.
Abra a janela para entrar
For
o
25
oxigênio, porque
years,
nós
scientists and
expiramos o
engineers
nitrogênio
from around the world
e
have been working to
respiramos o
design and build
oxigênio
a
aí, ó.
revolutionary window into the early universe. NASA's James Webb Space Telescope.
The James Webb Space Telescope will be
Ó, vira os colchão
biggest
tudo para limpar
and
os quartos.
most complex telescope that
Tá
NASA has
vendo?
ever built.
Ó, esse quarto é
Telescope that will
especialmente
test the boundaries of human ingenuity
de
to
Julinho
find
e
and probe some
Duda.
of the
Tô
farthest
limpando,
objects
fazendo a
and reveal
limpeza
new
toda para entrar
details about
oxigênio
some closer to home.
todo limpo. Esse é o quarto aqui de Julinho e Duda.
In late December of 1995, as kids unwrapped their holiday presents, the
Aí,
Hubble Space Telescope pointed
agora eu
toward a
vou
small
limpar.
region inside the Big Dipper and stared for 10 days. To the naked eye, it was an empty patch of sky. But that's not what Hubble saw.
This little blank piece of sky was found to have thousands of galaxies in it.
That's Eric Smith. He's the program scientist of the James Webb Space Telescope. The image he's talking about, the Hubble Deep Field, was packed with galaxies of different shapes, colors, and sizes. For the first time, we saw what the universe looked like almost all the way back to when it formed. Almost.
Astronomers learned that none of those galaxies were the first galaxies to form. And they realized then that as fantastic as Hubble is, it wasn't the right instrument to detect those first galaxies. And so this early measurement of Hubble pointed to where its successor needed to go technically.
The Hubble Deep Field image made scientists wonder, what if we created a telescope that could detect those baby galaxies? So scientists and engineers at NASA began designing a new tool that would be bigger and more sensitive, the James Webb Space Telescope. It will see deeper into space than we ever have before. And the farther we can see in space, the farther we can also see in time. That's because telescopes are like time machines.
And that's not a metaphor, that's actually literally true.
Amber Strawn is a project scientist for the telescope.
That really stems from the fact that light takes time to move through the universe. If you look at a light bulb across the room or look at a street lamp across the street, the light from those light bulbs takes a tiny fraction of a second to travel across the room to get to your eye. And so you're sort of seeing that light bulb as it was a tiny fraction of a second ago. So you can sort of think about things that are more distant. You know, the light from the sun takes about 8 or 9 minutes to get to the Earth. So we're seeing the sun as it was 8 or 9 minutes ago. The Webb telescope, one of the most fundamental and most crucial things it will be able to do is look back into time and see some of the very first galaxies that were born after the Big Bang. That's looking at a part of space that we've never seen before.
Looking at baby galaxies will give us an idea of how our own galaxy formed. And there are a few things that make Webb perfect for getting a glimpse at them. The first is its sensitivity.
A lot of the things that we're trying to study are either very faint inherently, or they're very, very far away. And so you need a really big, powerful telescope in order to see them. So when you factor in the size of its mirror, the amount of light it will see, and also the sort of new type of detectors that we have, the Webb telescope will be overall about 100 times more powerful than the Hubble Space Telescope. The Webb telescope will have the sensitivity to be able to see the light of a bumblebee at the distance of the moon.
Webb is so sensitive that it can see the details on a U.S. penny from 24 miles away. Another thing that makes Webb special is the kind of light that it will collect. It's light that our eyes aren't designed to see, infrared light. Eric explains what that means.
Infrared light is what we commonly think of as heat. So if you imagine you have a sunbeam coming through your window and you put a prism down there and you see it splits the light up into the rainbow from blue to red. If you were to put a thermometer to the right where that red light was, you would be registering the infrared radiation that's coming through as heat. You would see that thermometer going up. So you are detecting infrared radiation there. What Webb is going to do is be optimized to detect that heat radiation.
But why do scientists want to capture infrared instead of visible light?
There are two reasons for that. Webb wants to look at the earliest galaxies to form in the universe. When they formed early on, that means they've been participating in the expansion of the universe. And so their light, as the universe expands, gets stretched out. And the light that started as visible light has its wavelength stretched into the infrared, even though they're emitting the light as visible. By the time it gets to us, it's infrared. And then the other reason is that infrared light can penetrate the clouds of dust where stars form in our own galaxy.
Dust is great for creating things like stars, but it can block our view of objects in the sky that we want to observe. Infrared light waves go right through the dust, allowing us to see things that have been hidden. Webb sensitivity also makes it a powerful tool to look at exoplanets, planets outside of our solar system that don't orbit the sun. The observatory will look at these planets' atmospheres in detail, even searching for signs that they could be habitable.
I'm looking forward to, a few years after Webb is flying, to be out in the night sky, pointing up there and saying, you see, a little bit to the left or right of that star, there's a star that we can't quite see, but around it orbits a planet that could host life similar to ours. And that will be a pretty profound moment for humanity, I think.
With this new telescope in town, you might be wondering, what will happen to the Hubble Space Telescope after Webb begins doing science?
Hubble's become this world icon because of its beautiful images.
Crisp portraits of Jupiter and its shrinking red spot, blue and orange glows from the relics of supernovae, or pink dust clouds where stars are being born.
They connect with people on a deep level because they're so beautiful, and it just sort of it gets to the deeper levels of us as humans, of our need to connect to something that's outside of ourselves.
Hubble will still be very important for our exploration of the universe. In many instances, the telescopes can work together to get a more complete understanding of the objects in our skies.
They'll be complementary because they're optimized for different uses of the spectrum. And the best way to do science would be to combine observations of Hubble and Webb. Now, because Hubble has operated for 30 years, it's looked at a lot of things. And you can bet that what people will do early on is take Webb and go look at some of those same things to use both data sets together.
You may have seen photos of Hubble, a silver cylinder with solar thermal wings. Webb, however, was completely different. To construct a telescope that could look beyond what Hubble can see, NASA scientists and engineers had to think outside the box, or in this case, outside the tube.
So when you think about a telescope, you're probably imagining your sort of backyard telescope, like a tube with a mirror at the end. And if you think about the Hubble Space Telescope, that's what Hubble's like. It's like a huge tube with a mirror at the end of it up in space. But the James Webb Space Telescope is completely different.
It looks like a space machine from the future.
It's very sort of sci-fi, future space tech looking.
The telescope looks so futuristic, in fact, that it was once mistaken as a work of art.
I can remember many years ago we took a full-scale model of the telescope to New York City, set up at Battery Park. A young couple came up and obviously looked like artists, very bohemian.
Aqui o banheiro mais cheiroso do Brasil, interditado por paletó de bosta, Luca, advogado de sindicato, e botando polícia para querer bater em Bárbara.
As an art installation.
Esse ministro do STF a extraditar o louco do Léo, que tá dopando Bárbara e batendo com médico de coração, para dizer que é coração. É o banheiro mais cheiroso do Brasil.
It was honestly a little bit emotional. It sounds weird to say it. It's just this, it's a telescope. It's a machine.
E peça a Júlio para se sair de junto de Carlos, que a puta do café deu uns negócios parecendo de massa de bolacha para querer fazer doping em Júlio, lá em Carlos, ali na guarita.
Top to bottom, it stands about 4 stories tall.
Você sai de lá.
It has a gigantic kite-shaped sun shield that's about the size of a tennis court.
The sun shield is made of 5 layers. Each aluminum-coated layer is as thin as a strand of human hair. The sun shield will block light and heat, not only from the sun, but also from Earth and the moon. But the star of the show is what sits on top of the sun shield.
It has this beautiful, iconic golden mirror that's made out of 18 separate golden hexagons.
The golden hexagonal mirrors that adorn Webb look like a shiny honeycomb. But the gold isn't just about aesthetics. Gold is really good at reflecting infrared light, the stuff that Webb wants to observe. The mirrors and the sun shield will fold together for launch, and then expand like a transformer in space. What struck Amber most when seeing Webb is the people that had a hand in making it a reality. Webb represents an enormous collaboration involving NASA, the European Space Agency, and the Canadian Space Agency, as well as the Space Telescope Science Institute and Northrop Grumman. Thousands of engineers worked on the project. And let's not forget the scientists at universities across the world who will use Webb for their scientific inquiries.
It was the representation of decades of work that, thousands of people have put in to bring together this awesome machine that will change fundamentally our understanding of how the universe works. The fact that we're going to send it to space just blows my mind.
To get a telescope like this prepped for spaceflight, the team has had to go through a number of tests, like when Webb was recently put on a vibration table.
And this is where we shake the whole observatory with the same violence and frequencies that it will feel when it rides the Ariane 5 rocket into space.
This test, where Webb was vibrated at a frequency of up to 100 times per second, was performed in early October 2020.
So we've now subjected it to a simulated launch. Then we will undergo all the deployments that it will do in space,
as well as electronics tests, software tests, and a test where the telescope is cooled down to the temperature it will operate at in space. These tests are like a dress rehearsal for when Webb is actually sent to space. The next step is to get it to the launch location across the Panama Canal. The telescope is about to go on a cruise.
Literally, it will take a boat ride down to French Guiana,
to a space launch facility in the city of Kourou. The location is close to the equator, where Earth's spin is faster than anywhere else on the planet. That spin will give the Ariane 5 rocket a little extra push as it takes off with Webb in the fall of 2021. On launch day, it will be sent on a 30-day journey to a special place called a Lagrange point. There's a lot of math involved, but basically it's where the gravity of the Earth and the Sun combine to make a stable orbital point that follows Earth around the Sun. This allows an object like Webb to stay put relative to Earth. One of these points is located about 1 million miles away from Earth, about 4 times farther away than the Moon. That is where Webb will explore the universe. The launch is both the culmination of years of effort and the beginning of what will be decades of breakthrough scientific discoveries. There is a lot of anticipation.
Thinking ahead to launch, it's hard to know what will all be fun. I've been working on the Webb team at NASA information. But of course, there are people on the web team that have literally spent their whole careers on it. I mean, these huge telescopes, these big, groundbreaking missions, people spend their entire careers on.
People like John Mather, Nobel laureate, who has been with Webb since conception. In 1995, he got a call from NASA headquarters.
We're going to start a study of this new telescope. Do you want to work on it? And I thought, I've never heard of anything so exciting before. I'm going to do that.
He's been able to see the project grow from an idea to a fully assembled machine.
When we started off in the beginning, we just had words. Bigger and colder, that's what the committee said. And then we had pictures. We had a sketch on the big whiteboard that says it could look like this. And then we have hardware. Now we have real people putting it all together and making sure that it works. So you see, all in one glance, this entire history in front of you. And finally, something is getting ready for launch, and there's an awful lot at stake.
This telescope is not just for scientists, it's for the world.
As Webb travels to its final destination, it slowly deploys its many complicated components bit by bit, until finally it will get to work trying to answer some of those key questions Amber talked about.
Where did we come from? How did we get here? Are we alone in the universe?
And perhaps questions we haven't yet thought to ask.
For me, the most exciting thing will be when some young astronomer thinks of a different way to use this than we ever imagined, and they find something that we hadn't thought of. Those are the things that I think every scientist lives for.
It's those mysteries that are out there in the universe that we haven't even dreamed of yet. I think the universe is going to surprise us.
This is NASA's Curious Universe. This episode was written and produced by Liz Landau and Margot Wohl. Our executive producer is Katie Atkinson. The Curious Universe team includes Maddie Arnold, Michaela Sosby, and Vicki Woodburn. Special thanks to Laura Betts, Ryland Heggie, Natasha Pinole, Felicia Chow, and the James Webb Space Telescope team. If you liked this episode, please let us know by leaving us a review, tweeting about the show at NASA, and sharing this episode with a friend. You can learn more about the Webb telescope by visiting jwst.nasa.gov. Still curious about NASA? You can send us questions about this episode or a previous one, and we'll try to track down the answers. You can email a voice recording or send a written note to nasa-curious-universe@mail.nasa.gov. Go to nasa.gov/curiousuniverse for more information.
I really like to think of Landsat as a very sophisticated smartphone camera orbiting the Earth. Every 16 days, it has fully captured imagery from all over the globe. I can literally drive around the Corn Belt, and I've done this at times, and see what's going on the ground, and then also see it in the Landsat imagery. It's a verification that what we see in the imagery is actually what's happening on the ground.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm Patty Boyd, and in this podcast, NASA is your tour guide. In this episode, we're going out to space, but not too far beyond our atmosphere. We're going to turn back around and take a look at Earth. We're exploring how data collected from space can help farmers on the ground. We're talking about a mission called Landsat.
NASA is engaged in the Landsat program because we observe the Earth from space. We observe it for many purposes. We observe it to help understand the atmosphere and how it's changing, the oceans and how the oceans are changing, and finally the land surfaces, the earth and the vegetation and the impact of the humans on our resources and how we use those resources.
That's Jim Irons. He's the director of the Earth Sciences Division at NASA's Goddard Space Flight Center and also the project scientist for Landsat 8. Landsat is a joint mission of NASA and the U.S. Geological Survey, or USGS. It holds the title for the longest continuous record of our home planet's surface from space. Since 1970, Landsat has archived images and data of Earth, offering scientists information about how our world is changing. But it also does something pretty surprising. This data helps farmers.
A farmer can look at Landsat data and determine basically how well their crops are doing. They can look at the crop report from the National Agricultural Statistical Service and determine what crops are being grown in their region or across the country so they can make decisions about planting in the next year.
We can learn a lot from Landsat data and imagery.
We use the imagery to literally try to establish what type of crop is growing in every field across the United States, to identify that a field is corn, or soybeans, or wheat, or cotton, rice, go on down the list.
David Johnson works for NASS, the National Agricultural Statistics Service. He's a geographer and also a member of the Landsat science team. He says that the Landsat imagery is crucial to the information NASS provides to farmers and consumers.
Once we establish what we think is growing in each field, we aggregate that up to come up with a statistic for the amount of corn area in a state like Iowa, or soybean area in a state like Illinois, or wheat in a state like Kansas. It's really for all the states, all the crops.
Farmers rely on this information to make decisions about crops. Those decisions have far-reaching implications that can even impact what you see on your dinner plate.
So it ends up impacting commodity prices as people try to understand if there's going to be a supply, an extra supply of grain in a given year, or maybe a deficit of grain. So Landsat is another tool in our disposal that helps us get at those area estimates.
Landsat provides us with a long record of information about the health and changes of our planet. So much so that it's hard to picture a world without it. But to really understand Landsat, we have to step back in time and look at where it all began.
I would say Landsat was way ahead of its time when it was first conceived and launched almost 50 years ago.
When it began in the 1960s, the program was still called the Earth Resources Technology Satellites. We tracked down someone who was there at the very beginning, Valerie Thomas. Before she got to NASA, Valerie had never even seen a computer before, so she started from scratch, learning everything she could about them. Valerie recorded her end of this interview on an old tape cassette
Tu sai de Guarita, eu ia suavizando agora, ó, filho do delegado pegando o Carlos para querer dopar NASA viu, dopando Júlio em Guarita. Sai de Guarita, perto de Carlos. Vem para casa, a cama já está pronta aqui, ó, para tu descansar. Hoje é sábado, tô comer tua comida. Vou fazer o almoço. A puta do café da netinha querendo pegar te dopar com a vasilha com tampa.
just go and do what your mother does, sewing, hair, which I did. But I still want to know about electronics. I want to know what makes things tick. My pursuit in growing up and going through college prepared me to not be afraid of the unknown and to try to figure things out.
That pursuit got Valerie to NASA just a few years before the Landsat program started. She was tasked to work on LACY, a solution to a problem the U.S. was facing.
When the first Landsat satellite was launched in 1972, it occurred just after an event that became known euphemistically as the Great Grain Robbery.
At that time, the U.S. stockpiled a lot of wheat, and if a country was having a problem with wheat yield or some other problems with crop failure, they could contact the U.S. and there was a project that started based on crop failure in the wheat in one of the countries, one of the large countries, and they wanted a lot. It turns out it was so much, it caused a lot of problems for the U.S. to be able to satisfy the requirement. Okay?
The nation wasn't aware of the problem in the rest of the world and sold the grains from her storage at a relatively low price, in fact, a real low price.
Cuidado,
It turned out that our farmers could have made a lot more money if
em
they had known
julho.
of the shortage.
Que aí passou o dublê do filho da delegada com o Carlos, querendo fazer dobro com as putas da sacola, querendo fazer barriga. As putas da barriga tudo atacando. Tudo na guarita atacando.
The opportunity to go down to Johnson Space Center, where the large area crop inventory experiment was organized. It was a multi-agency organization, and learn a bit about how that effort was being approached.
LACY was a project that showed for the first time that global crop monitoring could be done with Landsat satellite imagery, but there was a way for the U.S. to keep an eye on our crop from a global scale.
When I went to Johnson Space Center and started being introduced to people working with Landsat data, they assigned me a supervisor. He convinced me and about how important observations from space in general and how the Landsat program in particular, how exciting it was, and that it was really the future of Earth science to a large degree, and how it would drive what we know and understand about the Earth from this point forward.
Aí o leite bem quentinho, ó, que eu fiz para Júlia e para Duda, que é antidope, ó. Que a NASA viu, eles na guarita doparam o Júlio, ó, botaram remédio em comida. Aqui, ó. Tá aqui no quarto para Júlio beber.
Landsat helps us do that in a unique way. The imagery we get from Landsat goes beyond what the human eye can see, even though it uses technology we're all familiar with. While Landsat provides compelling images of the Earth's surface from space, its sensors are actually well-calibrated scientific instruments.
I really like to think of Landsat as a very sophisticated smart camera.
Almoço medicinal.
It captures not only visible imagery, so you and I would see with our eyes, but also parts of the electromagnetic spectrum.
Information for the blue, green, and red portion of the spectrum that matches the response of our eye.
Landsat satellites go beyond what our eye is able to see. So Landsat collects images for that visible portion of the spectrum, but also gives us a lot more information. It goes into the infrared, where our eyes are not as sensitive. If you wanted to look at a Landsat image to get an idea about the state of the Earth, you can combine information from the multiple wavelengths of light that go beyond what our eyes can see. We call those false color images. And they can tell us about crop health.
Those false color images have the ability to emphasize or highlight certain features of the Earth.
And it's those aspects that really let us get a strong clue about crop health, crop progress, crop condition.
And we can train computers to recognize those patterns and then produce maps that show the different types of land cover, the different types of vegetation on the surface of the Earth. And you start combining multiple images of the same area taken over time, then you can analyze how those patterns are changing over the time and infer even more information about the surface of the Earth.
So it's that digital imagery that we can piece together, overlay from back in time with the current date to give us how things have changed in terms of where crops are being grown, if the crop health is better this year than it was last year or 10 years ago.
And that record of information helps us keep track of the Earth's changes. We can see a lot from Landsat data, and we can make music with it too. Let's take a listen to what a long record of Landsat data might sound like. You hear that? High-pitched strings plucked periodically indicate use of land where 6 of the world's major crops are grown. Those are corn, soybeans, wheat, alfalfa, cotton, sorghum. The higher the pitch, the more acreage Landsat recorded. Every slap of the guitar is a year, starting in 1995. Let's listen again with that in mind. What you just heard is called data sonification. Music driven by data, like a chart for your ears. Listening to data helps us think about it in new ways. Like in this one, you can hear the acreage growing as the pitch of the guitar strings gets higher. Now we can look at decades of information on crop health with accuracy, but that wasn't always the case. The Landsat program's early technology paved the way for that possibility.
Landsat was digital way before most of us knew what a digital camera was, so it really was ahead of its time.
There's a lot we can tell from Landsat data and imagery today, but the program had humble beginnings. It took a few visionaries, like Valerie, to set the groundwork.
I got on Landsat in 1970. The first Landsat was launched in 1972. So I got in on that project at a very early stage. During that time, to write programs, you had to be either a mathematician, engineer, or scientist. Turns out during that time, there were no computers at people's desks. The computer was in another building. They had key punch machines, they could go and key punch. There weren't these various apps, operations, and other kinds of things that people use now.
Back in those days, Landsat scenes were analyzed almost one at a time. Some of it was computerized analysis, but it was slow.
Daily, a mounting volume of images
imagery going to a long list of subscribers at universities and research agencies, as well as individuals around the world, providing us with a more complete view of that world than we ever had before.
When I first started working with Landsat data, we'd print out information on an alphanumeric printer.
Man began the first comprehensive inventory of his earthly resources, and he launched a valuable new means to manage those resources.
We'd hang those printouts on a wall and sometimes color them in with magic marker or colored pencils.
Earth, a new chapter in space. In fact, a new chapter in man's effort to prove himself worthy of his earthly heritage.
Got back to Penn State, I was really ahead of the game. I would watch a single image drop into a television display with one line of pixels at a time, and then I would work at night and turn off the lights so I could record those maps on a film camera and then tape them into my thesis.
It took a while for the infrastructure for computing to catch up to that. But with the really the foresight those minds and engineers had in the past, the historical data it's very important also because we need to look at the past to get an idea of what's happening in the current day and for understanding if something really is an anomaly or not.
Thanks to that long record of data, we can see things like spikes and anomalies. We can track changes over time, and we can ensure there's not another great grain robbery. Because we can track how our crop health and supply are changing over time. 8 Landsat satellites have been launched since 1972, and NASA plans to launch a new one in the fall of 2021, Landsat 9, which will continue Landsat's legacy and contributions to us here on Earth.
The technology has just grown over my career in ways that I had never imagined, but I think some of the people who began the Landsat program back in the 60s, maybe they were more prescient than I was kind of envisioned the growth of the program, the growth of the technology as it is today.
This is NASA's Curious Universe. The Curious Universe team includes Klaus Meyer, Michaela Sosby, Margot Wall, and Vicki Huber. Our executive producer is Katie Atkinson. Special thanks to Ryla Teggy, System Sounds, Mike Veli, and the Landsat team. If you liked this episode, please let us know by leaving us a review, tweeting about the show at NASA, and sharing us with a friend.
Overall, the project was excellent. When I was going through it, I felt like the female version of Superman, able to jump over tall buildings in a single bounce and faster than a speedboat. That's what I felt like.
Still curious about NASA? You can send us questions about this episode or a previous one, and we'll try to track down the answers. You can email a voice recording or send a written note to nasa-curiousuniverse@mail.nasa.gov. Go to nasa.gov/curiousuniverse for more information.
Without the sun, we would not be talking today, and no one would be able to listen while drinking coffee or a cup of juice. We couldn't go to work, we couldn't go to school, because the sun is ultimately the source of all of the energy in our solar system and in us even. But it can also be the source of destruction if we don't pay close attention. Most days the sun appears to be happily hovering over us, providing warmth and light, but it does have this bit of a mean streak, if you will. The sun is very dynamic. It's constantly changing. And you zoom on it and stare at it. It almost looks like it's breathing.
This is NASA's Curious Universe. Our universe is a wild and wonderful place. I'm Patty Boyd, and in this podcast, NASA is your tour guide. As Earth makes its annual journey around the sun, we experience that journey in the form of seasons. Earth's tilt in relation to the sun determines what season we experience here on Earth. But did you know that the sun goes through seasons too? The sun doesn't have seasons like you and I experience. Its seasons of activity come and go every 11 years or so in what's called the solar cycle.
If you've ever been around a toddler, you probably experienced how they have bursts of playful activity followed by complete crashes, often with a meltdown in between, right before they finally give up and fall asleep on the floor right next to their bed. But this will repeat the next day and the next day and the next, all leading up to nap time. And sometimes the meltdowns are mild, and other times there's lots of screaming and tears.
That's Sabrina Savage. She's a solar physicist at NASA's Marshall Space Flight Center, and she studies what it means to live with a star. Just like a toddler, the sun has highs and lows. Sometimes the sun is very active with random bursts of activity, and at other times it's quiet. But over the span of a decade, there is a distinctive pattern of the sun that scientists can follow. The active period is known as solar maximum. This is when there is lots of activity happening in the sun, such as solar flares and sunspots. When the sun is in its quiet phase, it is said to be in solar minimum. During this time, there's less activity, and the sun is pretty calm. Recently, scientists announced that our sun has entered a new solar cycle, Solar Cycle 25. This means it's the 25th solar cycle we're monitoring since regular records began in 1755.
We just recently moved over to a new solar cycle, which is quite exciting. The last cycle was fairly mild, and many experts who model these global flows and activity trends expect that the new one to be similar and to be fairly mild. But that does not mean that we are in the clear at all. Large eruptions can happen at any time.
To us, the sun and the stars appear calm as they twinkle in the sky. But the surface of the sun is anything but tranquil.
And that's because the sun is made entirely of plasma. It isn't solid, and so it doesn't all rotate together. The sun actually spins faster at the equator than it does towards the poles. And this plasma of ionized particle soup creates very large magnetic fields that actually wrap around the whole sun below the surface.
As the plasma particle soup churns, electric currents create magnetic fields. At home, when you put a magnet on the fridge, it's held in place by a magnetic force that comes from moving electric charges. As the electric charges move, they create magnetic fields. These magnetic fields twist around the sun like big magnetized rubber bands. Imagine twisting the middle of a rubber band faster than the ends. When you let go, the middle will spin faster and drag the ends of the band with it. This is also what happens on the sun.
Things get messy really quickly. There's bound to be some twisting and tangling and working. And in essence, the plasma that created the field also ends up tearing it apart. In some of the messy places where those knots begin to form, magnetic fields are able to bubble up through the surface and form sunspots.
Intense magnetic fields that manage to poke through the surface appear as dark blotches on the sun. We call them sunspots. These are areas of high magnetic activity that can be up to 10 times bigger than Earth. In visible light, which is what we see with our eyes, sunspots appear darker than the area around them. However, it's a little bit more complicated than that up close.
You'll see all of these writhing, connected magnetic field lines, and all of this plasma traveling along those fields, and it just looks like it's pulsing. the whole time. And that's because of all of the convection underneath the surface that's causing that and moving all that plasma together. It's really quite a beautiful thing. And so, very roughly speaking, it takes about 11 years, give or take, for the sun to cycle from a smooth, quiet, global magnetic field where there aren't that many sunspots on the disk to one that is experiencing a lot of activity with a bunch of sunspots and a lot of eruptions at any given moment. So, it's all due to magnetic fields.
How many sunspots appear on the sun plays an important role in the solar cycle. They show scientists when a new solar cycle is starting and when there may be more activity from our star.
So the sun has some kind of seasons on it that are related to the number of sunspots that are visible on the surface.
That's Dean Pesnell. He's the project scientist for the Solar Dynamics Observatory at NASA's Goddard Space Flight Center.
So a sunspot appears to be a dark region on the surface of the sun. They've been regularly observed since the early 1600s when people developed the first telescopes, but they have been recorded for about 3,000 years.
The history of sunspot counting goes back centuries. Scientists today count sunspots almost the same way as they did 200 years ago. If you brought an 18th century astronomer to a modern observatory, they would still be able to count the spots. Today's satellites and high-powered telescopes are great for figuring out how the sun works. However, when it comes to counting sunspots, we stick to the centuries-old method. That's because modern telescopes are just too accurate.
The problem with modern cameras is they see spots that are much smaller than a human would have seen 200 years ago using the telescopes that they have.
We want to be able to keep using that long record of sunspot data, and that means consistent measuring. Every day, all around the world, solar observers count sunspots by physically drawing a map of the sun. With a pencil and paper, they are able to trace sunspots using the sun's light.
And they have a telescope and put a piece of paper into a binder clip that they have there. And they shine the sun onto it, and they make a couple adjustments. And then the person basically draws. They trace over what they see projected onto that piece of paper. And once that's done, they take the piece of paper and they take it away from the sun and put it over someplace else. And then they go through and they count the number of sunspots they see, and then they actually group them into families. And then that becomes the first official sunspot of that day.
Sketching out sunspots may seem like a pretty simple task, but it can be tricky when the sun has lots of sunspots during solar maximum, and the people sketching sunspots need to work quickly.
They need to finish this in a certain short period of time to make sure it's the same kind of sample. And you can just see them sketching furiously, trying to make it from one side of the sun to the other, to pick up all the details that they can see with the human eye. But we see much more detail now with our telescopes. So we rely on these hand-produced diagrams to do the sunspot number, even as we use the more precise and more accurate data to figure out what's actually happening to produce sunspots and where they go.
That sunspot number is very important for charting the solar cycle. But the number of sunspots isn't the only important measurement. There are several ways to track solar cycle progress, such as the location of the sunspots themselves.
So as the cycle progresses, the sunspots begin to appear closer and closer to the equator. And so if you map out where the sunspots appear over time, it looks a lot like a butterfly with its outstretched wings outlined by where the sunspots first appear, moving from the poles to the equator. And we call this a butterfly diagram because we're very clever. These butterflies overlap a little bit, which makes it tricky to announce a brand new cycle.
Scientists keep track of sunspots to determine when there will be other types of solar activity. That's because huge solar explosions often originate from sunspots. We keep a close watch on the sun and its cycles because the sun's outbursts can impact our technology on Earth. The most famous of these solar storms happened in 1859. British astronomer Richard Carrington peered through his telescope and saw a bright, dazzling light blazing from a dark region on the sun.
Shortly thereafter, there were great auroras so bright that people at mid-latitudes could actually read newspapers by them. So that is what we call the Carrington storms.
That's Dolores Smith. She's a research professor at the University of Colorado Boulder, and her area of study is space weather. She studies how the sun's activity affects the solar system, which includes us here on Earth, too. Magnetic storms that the sun sends out can have dramatic effects on Earth. The Carrington event was so powerful, it lit the skies with bright aurora as far south as Puerto Rico and sent floods of electric currents that threw telegraph networks into disarray.
The Carrington event is the event where we had our first intersection between a great solar storm and a technology that we had become very dependent on. And that technology was the telegraph. What came with that was the absolute garbling of telegraph signals worldwide. And that went on for many hours. I believe it's important to know how this episodic and cyclical nature of the sun's extreme behavior can impact society. We are a very large, globally connected society that relies heavily on technology, and there are ways that this technology can be interrupted very quickly and very globally by the sun and its eruptions.
These impacts are the result of powerful solar eruptions known as solar flares and coronal mass ejections.
So it's not just sunspots, it's all these other things that are related to the sunspots that go with the solar cycle that make it interesting to study.
Solar flares are sudden outbursts of electromagnetic energy. These bright flashes can last from a few minutes to a few hours, kind of like fireworks on the sun.
There are the things that the sun does to get rid of the magnetic field. The magnetic field has gotten so strong, it actually is converted into heat. And we get a big, bright flash of light called a solar flare. But the sun still has magnetic fields sticking above the surface that it would like to get rid of. And it does that by throwing the field off in what we call coronal mass ejections.
These coronal mass ejections mean serious business. As the sun churns and appears to breathe, it can hurl particles into space like a great big sneeze.
And so when it sneezes, it could throw out mountains of material traveling at hundreds of miles per second through interplanetary space. And that happens to be where we live.
That material can't pass through Earth's atmosphere to hurt us down on the ground. But at its very worst, it can affect our technology.
The coronal mass ejections, as they pass by the Earth, can interact with the Earth's atmosphere, with the Earth's magnetic field to cause the aurora and to cause outages in things like power stations. They can interfere with communications. They use radio waves. We have a couple of examples later on in history where one of these coronal mass ejections actually affected something here on the Earth. The most famous is the one in March of 1989, which affected the eastern parts of the United States and Canada by taking out the power transmission lines. And so it caused power blackouts in parts of the eastern seaboard of the United States and Canada.
The March '89 event was a 1-2 punch that actually set up our power grid, it seems, for
more of a disturbance than we were anticipating. While the eruptions occurred on different days, the arrival of the material seems to have happened on the same day. And so Earth's system, its atmosphere, its magnetosphere, its sphere of charged particles that surround Earth really did not have time to recover between the first event and the second event.
The 1989 event showed the world that we need to prepare for solar storms. These disruptive events are not a matter of if they will happen again, but when.
And this is becoming a growing problem if you think about it. As we become completely dependent on technology, especially our space assets, and these coronal mass ejections can wreak havoc on communication satellites, GPS, and power grids.
So now it becomes kind of imperative for scientists who are looking at this going, okay, what could happen next? What ways does nature find to disrupt our new favorite, absolutely essential technology?
So understanding what drives the sun and how to anticipate its outbursts are extremely important, especially as we become increasingly reliant on satellite communication and continue to expand beyond the Earth's own protective magnetic field.
While scientists have been able to unlock many of the sun's mysteries, there are still questions left to answer. From the first solar spacecraft Helios to the recently launched solar orbiter, NASA has a long history of studying the sun.
We now have eyes constantly staring at the sun with extraordinary resolution. Just one picture has been taken of the sun every second for the last decade, and we never stop detecting the works that it's constantly growing. We really see every blemish, we hear every sneeze, and we are just at the very beginning of the baseline of these extraordinary observations that we need to cover at least once a year. So we really are at the precipice of understanding the process of Earth. The sun is such an ingrained part of our lives. We don't know it. We take it completely for granted. It's just there, but it's a star. So we look in awe and wonder at the sky at night because it glitters, at least I do. It makes us think of how small we are and how much of the universe there is out there. But we really should be just as introspective of the daytime sky.
Without the sun, we would not be here today. It's so much more than a bright light in the sky. Our sun supports life on Earth, but it also has an unpredictable side that makes it important to study. Over the years, we've learned a lot about our sun. There's still so much to learn, and that's why scientists like Juliodudanasaobamafbihelena and next time we talk about the sun, maybe we'll think mysteries. To keep up with the latest solar cycle science from NASA, check out nasa.gov/solarcycle. If you liked this episode, please let us know by leaving us a review, tweeting about the show at NASA, and sharing us with a friend. Still curious about NASA? You can send us questions about this episode or a previous one, and we'll try to track down the answers. You can email a voice recording or send a written note to nasa-curiousuniverse@mail.com. nasa.gov/curiousuniverse for more information.
It dominates whatever is around it. You can feel as it comes by, you know, it shakes the ground a little bit. It would just amaze you at the size and the complexity of it. Think of something that's moving very slow, about 0.8 or 0.9 miles an hour. It's moving this big rocket. It's fun to get up every day and come out and work on a crawler.
Our universe is a wild and wonderful place. I'm Patty Boyd, and in this show, NASA is your tour guide. Rockets are what launch some of our heaviest and most far-reaching instruments into space. But what gets these rockets to their last destination on the ground? The launch pad. In this episode, we're exploring some of NASA's most powerful ground machinery, the crawlers. These one-of-a-kind, 6 million pound behemoths are what transport rockets and their mobile launch platforms so that they can make their ascent into space. And the crawlers have a long history.
You almost have to go all the way back to the beginnings of NASA here at Kennedy Space Center. That's where they built the launch vehicles.
That's the crawler's senior project manager, John Giles. The launch vehicles he's referring to are the rockets that would help NASA send humans to the moon for the first time. In the early 60s, NASA built the Saturn V rocket to carry out the Apollo missions. Saturn V was built upright and was a staggering 363 feet tall, with the Apollo spacecraft on top. That's taller than the Statue of Liberty, and somehow the rocket had to travel from the vehicle assembly building to the launch pad, 4 miles away. Engineers at NASA scratched their heads.
How do you get it there? Something 300 feet long is a little tough to put on some kind of a flatbed truck and roll. You can't really put it on a barge or float it there. So there were many studies done over the years, and they came up with the best way to get it there was to build this machine, this crawler type machine.
NASA needed a vehicle that could pick millions of pounds and transport it for 4 miles, all while keeping it level. But NASA couldn't just call up any company to make a machine of this scale. They looked to an industry making some of the most powerful machinery out there, the coal mining industry.
You see those giant trucks, those giant cranes that scoop up all the rock and stuff. The company that builds that type of equipment built this crawler. I think it's one of the most phenomenal pieces of engineering equipment ever designed.
The Marion Power Shovel Company worked with NASA to make 2 of the most specialized pieces of equipment on the planet, Crawler 1 and Crawler 2. They both live at Kennedy Space Center in Florida, but Crawler 1 mostly hangs out in storage, while Crawler 2 gets to do the heavy lifting. And here to give you a tour of that crawler are 2 of its operators. There's Brianne Roloff, who just graduated with her bachelor's in aerospace engineering.
Brianne, she's a blast to be around because she's young. To her, this is just so exciting and so neat.
This is my first job out of college.
And then there's Sam Dove.
Sam's on the complete other spectrum. Sam is a senior driver. Ice water runs through his veins. Nothing phases him.
I grew up in West Virginia as a farm boy driver. 4 years in the Air Force. And then I was fortunate enough to get a job in the space program down here. I spent the first 10 years as a design engineer. And then I became a crawler driver. So it wasn't just something I stepped off the street and did.
Brianne and Sam both maintain and drive the crawlers. It's a truly unique job. And Brianne still vividly remembers the first time she saw a crawler.
I just remember, like, this is massive. It really reminded me of when you take off in an airplane. You start to gain altitude and you see all of the things that you normally think of as being big, buildings and houses and cars and cars. And that's kind of thing that I remember thinking, wow, people are so small compared to it.
It's really really not something comparable to what a lot of folks see.
It's kind of like you took a steel one-story building and sheared off the top of it so it's completely flat.
Steel box, basically.
Steel box that's bigger than a baseball field. The crawler's platform, which needs to be big enough to accommodate a launcher rocket. Inside the steel box, below where the cargo will sit, is a whole host of important things to keep the crawler going and to keep it level.
Cables, fans, motors, pumps.
And the crawlers don't move on wheels, but on tracks, like a tank. There are 8 total tracks.
You think of a giant bulldozer that we on each board.
These tracks are heavy duty.
The tracks are made up of little segments. Well, the crawler segments are called shoes, and they're big. They're 6 feet long and about, I think, almost 18 inches wide, and they weigh 2,000 pounds per shoe.
With 456 shoes on each crawler, the shoes alone weigh almost 1 million pounds. Once you add up the rest of the equipment in the crawler, the total weight comes to 6.5 million pounds. And that's without any cargo on top.
That's how big the crawler is.
Once you add the rocket and the launcher, that's when things get really heavy.
Almost 25 pounds.
I really don't think I fully understand how heavy that is.
So you may be thinking, can a normal road withstand the pressure of a crawler?
So when the crawlers were first built, they did try to roll them on roads out here.
Needless to say, the asphalt roads did not fare so well.
We put some cracks in them.
So it just tore it up.
Once again, NASA engineers and contractors had to get creative and design something that could support the hefty vehicle. Just like the crawlers, the crawler way is one of a kind.
Everything's special about the crawler way. I mean, first of all, it's the size of an interstate road, right? You have 2 lanes on one side and 2 on the other in the median.
But what's most special about the crawler way is what it's made of.
It's filled with crushed and compacted limestone, hydraulic fill under that, and on top of that, about 8 to 10 inches of gravel.
That gravel is actually Tennessee River rocks. That's what the tracks make contact with.
And the river rock becomes the sacrificial component because the crawler doesn't have shock absorbers like your car does. And when you're carrying a multi-billion dollar launch vehicle on top, you don't want to shake it to death while you're rolling it. So the crushing of this rock attenuates the vibration.
As more and more rock crushes into finer pieces, it has to be replaced to make sure it can continue to be a good shock absorber for the crawler. Rollout days, or when the crawler actually makes a trip, are big affairs. The team, composed of about 30 engineers, gathers 4 hours before the roll, around 8 p.m. They go over the mission, talk safety, and discuss who is in charge of each task. Then the team fires up the engines, which take 45 minutes just to heat up.
The first thing that lets you know we're starting up is you use compressed air to start these large engines, and it just goes, and it just gets louder and louder. And then the second the engines start, that noise goes away, and then you'll just hear this, and some black smoke comes out.
Then the rest of the systems get going. The pumps, the lubrication system, the hydraulics, the fans, all with their unique sounds.
It really has sounds all its own. You really need to be attuned to what their sounds sound like. If it's not running right, you can almost immediately tell when you need to start looking at something.
If everything is running properly, the crawler will pick up its freight by rolling right under the launcher. It's usually around midnight when the crawler begins its journey to the pad. To transport a rocket to the launch pad, the team breaks out into the individual posts. There are technicians on the ground constantly checking the position of the crawler.
If you're walking alongside of it, it's dusty and there's bugs flying around. And then you just hear these shoes that just constantly just slapping on the ground. And it just never goes away. They just keep rolling.
And then there are the people on board.
There's probably about at least 10 people on the crawler at any time. You'll have 3 engineers that are actually operating something at one time: the test conductor, the leveling system operator, and a driver.
All of those people have backups, people to switch out with if they need a break. This is very important given that the journey to the pad takes 8 hours. Why does it take so long to travel only 4 miles? Well, the crawler rarely goes faster than 1 mile per hour.
The speedometer shows 0 to 2.
Driving such an enormous vehicle is an experience few of us will ever have. But Sam tries to explain what it's like.
Driving the crawler it's something like driving your car, except it's very slow. You're constantly watching your speed because you can't just do a drift through a curve like a NASCAR race car can. And with your car, any input you make to the steering wheel, you immediately see it, right? Because you're moving at a much faster speed and it's a smaller vehicle. With the crawler, you have to think ahead.
Going so slowly might seem like it would be monotonous.
Oh, no. Boredom's not something that you have on the crawler, right? You're watching where you're going, where you've been, where you're at, the speed, what you're steering. Because if the crawler catches you not paying attention, it'll remind you.
Driving a crawler can be tricky as is, but the team has to be aware of other things that might obstruct rollout, like forces of nature. Florida, where the crawlers are located, is the #1 hurricane and lightning capital in the U.S.
We don't like rolling, carrying very tall things during thunderstorms and lightning storms.
Lightning and a rocket are not my favorite combination.
So the way to get around that is we start rolling very early in the morning.
That's to avoid the afternoon, when storms are most likely to strike. The weather is one thing to watch out for, but another obstacle involves things on the ground, because the Kennedy Space Center rests on a wildlife refuge.
You are constantly on the lookout for wild animals.
We see bobcats,
Turtles.
Snakes,
wild hogs.
Coyotes are starting to come in here.
You kind of just sit there and you're like, oh, please don't come into the crawlerway.
Sometimes, though, pleading doesn't work. Animals can get in the path of the crawler, and that slows the team down.
There was like a 10 or 12 foot gator that was under one of the trucks. And, we had to call the wildlife officer to come and pull that gator out. And he was kind of like the crocodile hunter there, like Steve Irwin was. He just reached under and grabbed that alligator by the tail, pulled him up, trussed him up, took him to another part of the Space Center. It was the darndest thing you ever saw, and off we went.
And then there is the tale of the tortoise and the crawler, less well known than the tortoise and the hare.
One time we were going up the pad slope, and I noticed a tortoise. They dig burrows in the ground here, and this tortoise happened to come out of his hole while we were rolling. This vibration that we're making kind of got him a little uneasy, so he starts walking around.
The tortoise and the crawler were both heading up the ramp, side by side.
And this is a true statement. The tortoise beat us to the top of the pad. That's how slow we go sometimes.
I guess slow and steady doesn't win the race after all. The whole ride down the crawler way is leading up to the